Hey guys, how's it going? G Lamb Bio here. I guess just Joe Lamb. I don't know, Mr. Lamb, whatever you call me. I don't really care. This is our review for Le Chatelier's Principle. So hopefully you've already watched the video. We're just going to take a little bit of time just to kind of reflect, review, go back over it, go back over some key points, and hopefully answer any questions that you might have. This one's a little bit tricky, but as you guys know, as long as you follow the rules, read the directions carefully, you guys will be just fine. Okay. So when we talk about changes in equilibrium, there's a couple things we need to think about. Remember and recall when we talk about equilibrium that just simply means that the rate going forward is equal to the rate going the reverse direction. Okay, so again, it doesn't refer necessarily to concentration, it just means that the rates are the same. Now, concentrations will stay constant, but they will not necessarily be equal. Well, we can actually alter and change the concentrations in equilibrium. And we can do that one of really three ways. There's more ways, but we're only going to focus on three. One is by changing the number of moles. One is by changing the pressure. And the last is by changing the temperature. And so that actually causes a shift in the concentrations. When you shift concentrations or when you change something that's in equilibrium, it is going to work to reestablish equilibrium. Take a look at the example here on the right-hand side. We have a constant concentrations going all the way across, and then all of a sudden we add a bunch of nitrogen. Well, notice what happens when we added a bunch of nitrogen. All of a sudden the rate of producing NH3 increased, the amount of H2 decreased, and so that's kind of that type of thing that affects equilibrium. We end up with more product, right, than when we started. So these are the types of things we're going to be thinking about as we move forward talking about equilibrium and change. Well, Le Chatelier basically said when you make a change, to something at equilibrium, that particular system is going to respond by reestablishing equilibrium. Responds by re-establishing equilibrium. And that typically causes a shift. That shift is either going to be towards the product side or that shift is going to be towards the reactant side. Now, which direction the reaction shifts depends on what you are doing to the particular material. Let's look at an example here. Let's look at moles. So let's say I have an equation. I'll just use this equation because we're really familiar with it. Haber process. And let's say with this particular one, I add some N2. Okay. Now I have more N2 than what I would normally have at equilibrium. Well, equilibrium is going to reestablish itself by making more product. So if I add reactants, it is going to shift equilibrium to produce more products. Okay. The same thing would happen if I added more NH3. If I have more NH3, equilibrium will reestablish itself and shift and make more of these things. Okay? So that's the kind of thing you want to make sure you think about. When we increase the concentration of our products, it shifts the opposite direction. If we decrease the concentration, I'll use blue for that. So let's say that the concentration of N2 goes down. Well, I have less N2 than what I would normally have at equilibrium. So the reaction is going to shift to produce more N2. Okay? So if I decrease the concentration of my reactants, then it's going to shift to the left, meaning that I make more reactants. Okay? Or if I decrease the concentration of my products, equilibrium is going to shift to the right to make more products. Okay? So again, you just need to think about excess and less, and if I take stuff out, equilibrium is going to shift to make more of the stuff I removed. Or if I add more stuff into it, equilibrium is going to shift to get rid of that stuff in order to reestablish equilibrium. All right, let's move on. So temperature is an interesting one, okay? And when we refer to temperature, when we look at this, we're really referring to whether heat is gained or lost. Okay, and it's also important to remember our exothermic reactions and our endothermic reactions. Remember that exothermic reactions lose heat, and endothermic reactions gain heat. Okay, so we need to think about heat like a reactant or a product. Okay, so let's use that previous example. In this reaction, E has a negative value. Remember that if E has a negative value, then the reaction loses energy. So if it loses energy, heat is a product. Okay? And it makes sense. Exothermic reactions lose heat, so heat's going to be a product of that reaction. If it's endothermic, heat is a reactant. Okay? Now, you treat it just like you would if heat were some type of quantity that would be moles, just like what we did previously. So let's say that the temperature goes down. Well, if the temperature goes down, we lose heat, right? So equilibrium is going to shift to the right. So equilibrium is going to shift to the right to compensate for that loss of heat. Okay? Same thing if we were to say that the temperature goes up. Let me just get this. If temperature goes up, right, we add more heat. And if we add more heat, then equilibrium is going to shift to the left. Okay? So a couple things you need to make sure that you establish here. Establish whether it is an exo or endothermic reaction, and that tells you where to put heat. You put heat on the product side or the reactant side, depending on whether it's endo or exothermic. You also want to look for E as well. That will also tell you if it is endo or exothermic. Then you treat temperature and heat just like a reactant or product. If temperature goes down in this reaction, equilibrium shifts to the right to compensate for the loss of heat. Temperature goes up, we get a shift to the left because we have too much heat and therefore equilibrium shifts the opposite direction. Okay? Let's look at pressure. Okay? And again, I'm going to write the same equation I did before correctly the first time. So when we change pressure, that's going to depend on the moles of gas on each side. So when we look at pressure, if we increase pressure, the side with the fewest moles of gas is where we shift equilibrium. Well, here on the left-hand side, I have 3 and 1. That's 4 moles. On this side, I have 2 moles. Remember, this is gas only. Okay? So if the pressure goes up, we're going to shift to the right. If pressure goes down, I shift to the left. Something else to consider is volume, right? Because volume and pressure are related to one another, right? Remember that as the volume increases, the pressure decreases, right? So we can also argue that if volume increases, we shift towards more moles. If volume decreases, right, pressure goes up. So that would cause a shift to the right. So you just need to think about these things in terms of pressure, volume, how those two things are related, and then also that will help you determine with the equilibrium shift. A few more things to consider. Catalyst. We're adding something that is not part of the reaction. Those do not have an impact on equilibrium whatsoever, okay? So let's take a look at this problem here. In this reaction, we have CO2 reacting with hydrogen to produce carbon monoxide and water. It looks like heat is a reactant here, okay? So if heat's a reactant, it's going in, so we know that that's endothermic. So heat is absorbed by this reaction. Next thing asks, in which direction will equilibrium shift if the following changes are made? So let's think about it. CO is added, so CO goes up. Which way is equilibrium going to shift? All right, we add more product, we get more reactant, so equilibrium is going to shift to the left. Okay? What if the temperature is increased? So heat goes up. We're going to get a shift to the right. CO2 is added. Again, we add more reactant, we get more product. So we're going to shift to the right. The system is cooled, so heat goes down. We get a shift to the left. H2 is removed. Shift to the left. Pressure is increased. This one's a little tricky here. We need to figure out the number of moles on each side. So it looks like there's 2 moles to my left and 2 moles to my right. So there's no shift. Right? No shift whatsoever, because if the number of moles are the same on both sides, then it can't shift. And lastly, if a catalyst is added, then we just talked about that, no shift either. Okay? This just comes with practice. Practice, practice, practice. Please come find me if you have any questions or need any extra help. Take your time, read each question carefully, and we'll see you guys soon. Have a great day, guys. We'll talk to you later. Bye-bye.